Okay, this problem is going to be a little more involved. It will involve limiting reagents, and also we'll talk a little more about excess reagents. So let's look at the chemical reaction first that we're going to be dealing with. And here you see, looks like a synthesis reaction. So the first task we're provided with is, of course, we've got to balance it. So there's the balanced chemical equation. The ratio is 1 to 24 to 8. There's our recipe. Remember, those are molar ratios. So let's see what they're going to ask us to do. So in part A, we are going to have to just determine what is the limiting reagent between the sulfur and the fluorine. So just like in previous problems that we've looked at, we want to examine how many batches will be produced. So let's start with the sulfur. Remember now, we've got to use molar ratios. We've got to get everything to moles. So we find the molar mass and divide by the molar mass. Remember, the entire equation represents a batch. And you can see that it requires only 1 mole of sulfur. So one batch requires 1 mole. And then we'll go ahead and do our calculation, and we find that we've got 0.292 batches. Now let's go to the fluorine and do the same thing. Again, we got to get it to moles first, so we're going to divide by its molar mass against diatomic, so keep that in mind. Again, the whole equation represents a batch, and you can see a batch requires 24 moles of fluorine. So we take that into consideration. We do our calculation, and we get many fewer batches, only 0.0932, which obviously makes the fluorine our limiting reagent. As soon as the fluorine runs out, this reaction will come to an end. Now, knowing that we've got the limiting reagent as fluorine, we're asked to determine the theoretical yield of the SF6. So we're going to use the fluorine to make this determination. Again, we've got to get this to moles, so we'll divide by the molar mass. I look at my balanced chemical equation, and I see that the ratio between product and fluorine was 8 to 24, so I get 1/3 of the number of moles of product as moles of fluorine that reacted. And again, theoretical yield, if they don't specify otherwise, I'm going to get that in grams, so I've got to multiply by its molar mass. And I find that I predict we're going to get 109 grams of SF6. Now, if we run the experiment ourselves, we're not usually going to get anywhere near the 109 grams we predicted. In this situation, a group ran the experiment and they only got 14.5 grams. So we're going to calculate the percent yield, which is again a comparison between actual and theoretical yield. Plug my values in, I can see I'm well below 100%, only 13.3%, which may not be that bad for that particular experiment. It really varies from reaction to reaction. Next, we're going to see if we can figure out how many grams of excess reagent were used up. So excess reagent, that means some of it's left over at the end of the experiment. So if fluorine was the limiting reagent, that means the sulfur must have been the excess reagent. So again, we just use stoichiometry. We're going to use our fluorine. We're going to get into moles by dividing by its molar mass. And this time we're going to compare the fluorine and the sulfur, the two reactants. And the ratio between them is 1 to 24. Again, I want this in grams, so I'm going to multiply by its molar mass. So I can compare any two things in my equation. I do my calculation, and 23.9 grams of sulfur should get used up as the fluorine runs out. And so lastly, what I'd like to figure out then is how many grams of that excess reagent, the sulfur, were left over at the end. So this is a simple calculation. You obviously are going to take what you started with, the 75 grams, take the amount we just calculated as reacting, 23.9, and the difference is the leftover excess reagent. So excess reagent sum will remain at the end of the experiment.